Hello everyone. Until now we have seen how we can draw things in our custom inspector or in an editor window. Now we will see how we can draw 3D or 2D GUI elements or 3D controls in our scene view. For this purpose we have two tools at our disposal. The first one is handles and the second one is gizmos. The only key difference between handles and gizmos is that some of the handles are interactable, so you can directly use the handle to control or change variables in your script. And however, the gizmos are purely cosmetic. They are only used as visual debugging tools, so you can show directly in your scene view the values of your variables. You must already be familiar with some of the built-in Unity handles. For example, the position handle, which is used to move game objects in the scene, the rotation handle, and the scale handle. Handles are useful when you want a more intuitive, interactive, and more visual tool to change any variable in your script. For example, it is easier to move this game object using the 3D position handle rather than directly inputting values in these position field. To show you the uses of some of the common handle functions, I have gone ahead and created a simple AI script, an empty AI script, and I have written a custom inspector for our AI. The steps of writing the custom inspector you can revise from my video on custom inspectors. So right now we are not doing anything fancy. We are just drawing the default inspector. The easiest handle to make is the labels handle, using which you can draw a simple label or text near your game objects. This is useful in cases when you have a very cluttered scene and you want an identification of your specific game object. Suppose if you have a group of AIs and you want to look at their names, you can even show their health directly inside your scene view. To do that, we will go inside our custom inspector class and write a function called void on scene GUI. This is the function that Unity uses to draw anything inside our scene view. So all our handles and any GUI that we want to add to our scene view, will have to write it inside this function. So to write a label for our game object, we will use the function handles.label, and the argument it takes are, the first argument is the position, the 3D position where you want the label to be. So let's make it at the same place as our game object. So ai.transform.position, and the GUI content can take the text that you want to show as your label. So let's name it, and we will also use the name of the game object in our label, ai.name, which is same as the game object name. Now coming to the scene view, you can see a text representing the game object, and suppose if you change the name of the game object, it will be reflected in the scene view label. One thing that you may want to do is change the height of the label so that it appears on top of the game object, not exactly at the game object. To do that, you can simply add a vertical offset to the position argument by writing, suppose let's give it a 5 units of vertical offset, and this will move this label 5 units on top of our AI. The first interactable handle that we are going to look at is the radius handle. Radius handle is useful in the case where you want to control a volume or an area which is associated with the AI. So think of it like your AI may have a vision radius inside which if the player comes, the AI will be activated or it may become aggressive. One method of doing that is by simply writing a float field in our custom inspector which will denote the radius of the area around the AI. So what we can do is make a simple float variable called uh, area radius, and since we are drawing the default inspector, it will make a float field for our area around which the AI can be activated. But this method is neither intuitive, neither it gives you any sense of uh, the area in respect to your scene. So you can never know how much area around the AI is really dangerous. Suppose you have a 3D scene view with other objects in your scene, it will be more beneficial if you can see directly inside your scene view the region in which your AI is dangerous. For that end, we can make a radius handle which will not only give a visual representation of the area around the AI, but it also gives you the interactive feature of directly increasing or decreasing the handle of the area radius of our AI. So to do that, we'll come to our custom inspector script and use the function called handles dot radius handle. So the argument that it takes are the rotation. We don't have to worry about the rotation of the radius handle because since the area is a sphere, so rotation doesn't really matter in this case. We will can the default rotation value is quaternion dot identity, and we'll use the same position as our AI. So AI dot transform dot position, and for the radius, this pattern is same as how we used to write for our editor GUI layout fields. We will input the value that we have to change. In this case, it is the radius, area radius, and the return, the changed value, we will assign it to our variable area radius. You will have to look it in the scene to make it more clear. In this case, the area radius is 0, so it is collapsed to the origin, so we can't really use it. So let's give it a more meaningful and more useful value. Now you can see the sphere around the AI. It represents a sphere of radius 2, and it also has this interactive feature of that you can directly change the area radius, and you can see the change reflected in our area radius variable. So in this way, you can directly visualize what is the area around the AI and that area corresponding to other things inside your 3D scene. The next useful handle which can be used to directly change a value in your script while also being visually represented in your scene is the scale value handle. Suppose you have a value associated with your AI, which is the speed at which the AI is moving. So let's have a float variable called speed, and to show this speed directly inside your scene view and to also control it, you can draw a new handle called handles dot scale value handle. It is a little bit more complex than the radius handle, and the argument it takes are it following the similar pattern, it will return the value that we are changing, and the argument list are the first argument is the value that we are going to change. The second argument is the position at which we want to draw our control. Similar as above, let's make it at the same position as our game object, ai.transform.position. The rotation, let's again make it the default rotation, that is quaternion.identity. And the size of the control, we want the size to be controlled uh, in the same manner as our value. So if we increase the value, let's increase the size of our handle. So suppose if we are drawing an arrow and representing our speed, when we increase the speed, we want the arrow to increase in size so to more better represent our speed. So as an argument of the size of our handle, we will give it ai.speed, and the this argument, which is the draw cap function, takes different types of handles. For example, you can make a sphere, you can make a cone, or you can make a circle. For this case, the best suited uh, drawing function is the arrow function. So we'll write handles dot arrow cap, and the last value is the snap value, which does exactly what it says. So you can have snap values between when you increase your values. Now coming to the scene view, let's give speed some initial value so we can see the handle. Right. So this yellow arrow here represents the speed of our AI. Suppose you have made a pathfinding algorithm for your AI, and suppose 10 or 20 AIs are moving in your 3D scene. You can use this arrow to directly visualize what are the speeds of your AI, and you can even change in your scene the speed values of a particular AI. So you can see here, as I move this GUI control, the speed increases. I can even make it to the negative. So this was the the slider handle, which can be used to visually change any particular float value inside your script. Some of the more useful handles are the position and the rotation handles. Position handle is the same tool that you use in your scenes to move your game objects in your scene view. Now we want to make this position handles for different elements in our code. So imagine a situation in which your AI is a node based pathfinder. So you have already defined some 3D nodes in your scene view. For example, here there are four nodes, and the AI basically follows a path between those nodes. So one method would be to directly define an array of points in your AI script, and the AI will traverse these points in order. So let's make a array of vector points, node points, and what you can do is assign particular 3D points in which the game object is and the AI is going to move. But there is no way you can be sure the AI is not going to move into an obstacle, it is not going off screen, etc. So you want a method in which you can visualize exactly where these points are inside your scene view. For that, we can use the handles.position function and also have a direct control over these position, so we can directly uh, control these points, position these points directly into our scene, and the change is reflected in the variables in our AI script. So inside our AI inspector, let's make position handles for all of our nodes, the travel nodes for our AI. So for AI dot nodes, right? And for each of these travel points, we'll draw a new handles dot position handle, and the arguments here are the position at which you want to draw the handle. In this case, we would want it to be at the position of our travel node. So this will be AI dot the node points, and we don't have to worry about rotation right now because the AI will just travel to that point in an upright position. So let's give it the default rotation, which is quaternion node identity, and the return position, the change position, we will feed it into our node points. Now when you come to scene view, you can see all these three node points now have a position handle. So you can directly manipulate all these positions inside your scene view. So let's move these position handles away. Let's move these node points away, and you can see these changes reflected in the position variable inside your AI. So you can place these position nodes anywhere inside your scene. You can directly view where these positions lie inside your scene, One more feature would be to add a line connecting all these nodes so you can better see the travel path of an AI. So for that we can simply write a for loop with which draws lines between two consecutive nodes. We can do that by AI dot node points dot length. We are just traversing the array and taking two consecutive points and drawing a line between them. For that we have the handles dot line function, draw line. It takes 2 points as arguments, 2 vector 3, any two given position inside the our scene view, and it will draw a line between those 2 points. So the first point can be the node points I, and the next point to draw the line is the next element in the array, I plus 1. Only one thing that we have to take care is that when we reach the end of the array we have to go to the first element. So for example, if we have three node points, we'll start drawing line between 0 and 1, 1 and 2, and when we reach 2 we'll have to draw a line between 2 and 0. So we will convert this I plus 1 and draw this nice function called math dot repeat. So what mat.repeat does is when you reach a particular limit, which is the second argument, the length, it will start repeating, it will bring you back to 0 and then start repeating from there. So if you are counting like 0, 1, 2, 3, and 3 is the length, your next element will be again 0 and then 1, 2, 3, 0. So it's like going in round circles till your length. So the limiting length in our case is the length of our array, which is ai dot node points dot length. This way we'll draw three lines. If we have 3 points, we'll draw three lines, each connecting the consecutive nodes and the last one to the first node. The only error here might be, yeah, we have to convert it to int because it is an the array index, so it must be int. Now when we come to our scene, we can see uh, these lines connecting into our travel nodes. Again, a new feature that you can add here is that you can change the color with which the handles are drawn. You can control that using handles dot color. So let's make our lines blue using color dot blue. So the next handle that you are drawing will be drawn with the blue color, like this. Let's add more node points to our scene. Yeah, and let's change the verticality, because the next feature that I want to show you is how you can also assign rotation to these node points. So for example, if your AI in this case is in a space game, so your AI is moving in a 3D space, and it is not only moving between this node and this node, you can also assign a particular rotation at this point. So the AI will move here and uh, between these 2 points, and also lerp its rotation while it is traveling between these two nodes. So what we want is an array of rotations for all these points. So we'll go to our AI script and let's make an array of rotation, which is represented using quaternions and node points rotations. Now this will store all the rotation at any particular travel node, and to control these rotations we will add a rotation handle with which we can directly change this rotation for our for any given node. So we'll use the same for loop, and in this case instead of using node points, We'll use node point rotations array, node point rotations, and instead of using the node points, we will use the node point rotations, and instead of position handle, we'll use the rotation handle. The arguments to the rotation handle are the rotation value which we are directly going to change, and the position at which we want to draw the rotation handle, which is same as the rotation handle that you may have been using in the default rotation handle used by Unity. So the first argument is the handle that we the rotation that we are changing, which is rotations with index I, node points rotation. and and the second argument is the position. So we want these handles to be at the same position as our node points, so that we can control the position and rotation at the same place. So we will give it the positions as the node points. Now coming to the scene view, you can see rotation handles at all the position of our nodes. But only one thing to take care here is that when you initialize these five new quaternions as the rotation of your nodes, when Unity initializes these values, it always assigns 0 in the place of W. But if you know a quaternion rotation, W at 0 is not a valid quaternion, and Unity will start messing up internally, and you can't control this rotation handle while the value of W is 0. So you will have to go manually and change all these W values to 1, and then your rotation handles will be functional. Now you can see when you change this rotation handle, this quaternion value changes. Now for all your nodes, you also have a position. You can change the position. You can also change the rotation. One thing that you may notice lacking here is that when you rotate an object using the default Unity rotation handle, this arrow, this position handle also rotates. So to reflect that in our own code for our nodes, what we have to do is come inside our script, and the place where we were drawing the our position handles, instead of the default rotation, we will assign it a rotation which is equal to uh, the rotation handle at that position, which is ai dot node point rotations with the same index. So now these two handles are linked to each other. So when you change the rotation, the position handle also rotates, and when you change the position, the rotation handle also moves. Now they both work together very well. So now this position handle will also reflect the rotation, and when you move the position handle, the rotation handle also moves. This both these are linked together, and using both of them, you can easily place travel nodes inside your scene and directly see where your nodes are with respect to other game objects in your scene. One complaint that you can still have is the scene is looking too cluttered. Now we have just a single dinosaur AI, and the scene is uh, already started scene has already started to look cluttered. So for that, we can have a simple bool checks inside our variable which controls if we show these handle controls or not. So let's just add a simple bool in our AI script, show node handles, and we want this bool to control if these node point position handles or the rotation handles are shown inside our scene view. So we will put this position handle drawing function, this for loop inside a if statement with our bool. So if AI dot show node handles, so it is only drawn when this bool variable is true. And similarly, we will surround the rotation handle drawing inside that if and bool statement. We can even add the path as the simple line that is drawn as a path between these nodes. Right. So now you can see, if we check this bool variable, we can see all the handles, we can edit the nodes, and if we are done editing, we can simply check this bool and we only see a clean node for our AI to move. So this was an introduction to some of the things that you can do with handles in your Unity scene view. You can make interactable controls. You can easily lay out your scene. You can visually look and control the variables in your class. But this was just a scratch on the surface of the potential of these handles, because handles can be used to do extremely complex tasks. They can input all sorts of events from your scene view. They can record your mouse event. So when you are dealing with complex procedural contents, like how the asset package curvy uses the handles to make bezier curves and those sort of things. So if you are dealing with procedural content, you can use handles to make easy controls. For example, if you are generating a mesh inside your scene view, like the asset package that is Procore, for those things you will need more complex handles and more uh, event capture in your scene view, and then you can drive those changes and controls variable in your scripts. This was just an introduction of some of the most useful handle functions. In the next video, I will talk about how you can add buttons directly inside your scene view, and then we will talk about gizmos, which are similar to handles but they are not interactable.